Wait for it. Wait for it. Oh my gosh, we fixed it up. Just had to reset the computer. Let's hope people join back in, but resetting the computer fixed it. So wow, I come in and the camera's not working. It's always great. It's always great. Well, let's wait. We had Noel here. We can work on some stuff. So I'm hoping people join back in. I might send announcements so people know we're live streaming on the interwebs. Live streamings on the interwebs. Nima, good to see you there. We got Mewbot here giving out points. All those Mewbucks. Who all is here? We can work on any assignment you want. Just say, hey, Brian, let's work on this. And we work on it. There we go. Oh, I'm already logged in. What shall we work on? I'm logging into my Pearson. Remind me later, my Pearson. Nick, good to see you there. Mewbot talking away in the chat. Chapter 4 quiz. What part of Chapter 4 quiz do you want to do? I literally... Gosh, your account has been locked. Hey, Noel, good to see you there. It is a crazy morning. Oh my gosh. Good morning, Kayla. Raptor, good to see you there. Watch me be like even logging into like the wrong My Pearson and getting scammed. Oh, that'd make my morning. That'd make my morning. There it is. There it is. Like, I seriously... There we go. Watch you be like, you can't use the same password. Okay. I don't say my passwords anymore. I'm always afraid of, like, you know, like, someone just gets a hold of your computer and it's like, oh, I got every password. Log into all your bank accounts. We're gonna do some Chapter 4 quiz, a national vital statistics report. I thought I did pretty well on my BS. Congratulations, Nick, right there. I thought I did well at logging into stuff, but apparently I didn't. A national vital statistics report. And let's get that open right here. We're placing questions. Let me open up Word so we can start working on this. The U.S. Department of Energy, you got it right there. Okay. Here we go. We're going to find those questions. We got the notes up and going. And we've got the video notes. And here we go. Okay, let's start this up at 4:03. Stat 201, Chapter 4, a National Vital Statistics Report. Let's go find that one. Here we go. Okay, a National Vital Statistics Report. Where is it? And if you see a number on here, tell me which number you want to do. Like if you see one as I'm scrolling through, like, oh, number 7. Oh, that was a good one. And then we can come back to it and do that question. And also, the first 3 words or so of a question is really great. We've done that. We've done the crowd crush one and the different types of things. Here it is, National Vital Statistics Report. Let's do it. This one right here, let's take a look at the data. And what we see here is 2 what? What are these called? I want you to give the name of this graphic. And what is this graphic called right here? What is the graphic? You want to look at this screen right here and look at what you see. What is this graphic called in its fullest sense? What is this graphic called? Use the information on the screen to know this is a bivariate display of data. What is this graphic called? So tell me if you can. So once again, you might be wondering, well, Brian, that's not what they're asking here. It is histogram, correct? Okay, let's give some points for that. It's histograms plural, and they're stacked on top of each other. And just good review. So these are stacked histograms, one histogram for white, one histogram for black, and they're stacked. So we're comparing 2 distributions, which is Chapter 4, comparing distributions. What you can notice here is that there is a peak right here for black, a peak down here that's a little bit higher. Does everyone understand, like, the point of this is to compare these distributions? And what you want to do here for this question is think, well, what do we see differences wise? Let's go over here to a Word document and we'll just think about it. So histograms measure what kind of data? Histograms measure what kind of data? What kind of data do histograms measure? What kind of data do histograms measure? What kind of data do histograms measure? What kind of data does histograms measure? Quantitative, it measures quantitative. Great job, Noel, right there. And when you do stacked, you're doing for two categorical, or you can do multiple categories, but stacking them means you're adding in a categorical X. So you're doing a quantitative Y of interest and then breaking apart the data into two groups or more. This is just a two-group stacked histogram. So you can see some differences right here, where the modal area for white is up here, the modal area for black is here, and also a second mode. You've got like 3 modal areas for black with like a smaller mode on the low side, but kind of a little bimodal on the right side. Modality is a little bit subjective. It's clear that the white one is unimodal, and it's very clear both of these are what skewed. It's very clear both of these are what skewed. It's very, very clear both of these are what skew. There's no debate about that. Right to the high, left to the low, whatever way the tail goes. So both of these are what skewed. Very left skewed. Is it always Y is kept? Usually, and here's the thing, usually we think of the X as the explanatory variable. Maybe race explains, and I think this is life expectancy. So that's what we're looking at here in this graphics from the National Vital Statistics Report. And so you can switch up that the Y is categorical, and that would do something like logistic regression, which we don't do in the class. Notice how the variable up here on the top side is the Y variable of interest. If we wanted a categorical Y with a quantitative X, you'd have to go across this way right here, and that would do what's called logistic regression. So this is all the bivariate stuff in here, and those are the univariate. The green means categorical, the black means a combination of the two, and the blue means it's quantitative. So take a screenshot of this and know how to read it, that you know the different types of plots like mosaic plots, contingency tables are all bivariate categorical, pie charts, bar charts, frequencies are all univariate categorical. Just knowing how to read this and knowing histograms are quantitative. If you stack them, you've added a categorical variable to them. Okay, so Y is down and X. If you look here, I'll show it again. Do you see how it says like the Y right there? Yeah, if you go down this way, you're using a quantitative Y variable. Everything here is quantitative Y. Everything here is categorical Y, because the Y up there is saying categorical. If you go down, even the top one up there, and then everything across here, because this is where you add in an X, is quantitative, where my hand is pointing across is quantitative X, and everything here is categorical X, because it says categorical on the far side. So a lot of people have asked, how do you read this graphic? It's the combination of all univariate. Up top is the univariate stuff, and then the bivariate is in here where you intersect. Like this intersects quant, so scatter plot's a quantitative visualization of two quantitative variables, bivariate quantitative. Okay, so we have here a bivariate visualization, and we can see the differences. Let's go answer it and find out what they want to know. And once again, we try to make sure we teach the things too, even though we're going to show you the answers. Describe the overall shapes of these distributions. They are left skewed, more modality on the white one, but they're both left skew. Both distributions are left skewed. The white one has one small peak, the black has 3. That seems accurate. The other ones, it says the white is skewed to the left and unimodal. The black is, no, it's not symmetric. They're both left skew, and that's a big tip right there. How do these distributions differ? Well, the black distribution had more modes. Let's see about that. The center for the distribution of the whites is less. No, the center for the distribution of the white is higher. That's not true. The range of the distribution of the blacks is less. No, it's basically the same. The range goes from 1 to 85, so. The range of the distribution of whites is less. No, it's not really the range. The center for the blacks is less than the center for the whites. It's males, all males, apparently. There we go. And the center, as you can see right here, we actually drew it in Word a bit better. This is kind of one of the big centers here. There's also another mode here, but you can see differences when you compare right there. So that's the big differences we're looking at. And here, look carefully at the bar definitions for the black distribution and the white distribution, and where do these plots violate the rules for statistical graphics? This is an okay question, and watch me get one of them wrong. The vertical axes do not have the same maximum. When you make plots, they should all have the same what axes. This is a part of chapter 3. No, it's part of chapter 4, I think. When you make plots, they should all have the what axes. Horizontal and vertical. Either or, if we mention them, they should have the what. 4-letter word starts with an S. They should have the what axes, which it's pointing out Here, I'll erase some stuff so I can focus in on just that information. We're not erasing you, Monster Man. No way we erase Monster Man. We're talking about this and this do not match. But this and this do match. Huge note, and if you're teaching to the test, your graphics should have the same what and what axes, which it does not right here on this. Your graphics should have the same what and what axes. And if it says one, like they should have the same horizontal, good, yeah, that's true. They should have the same vertical, that's true. So who can tell me in the chat for some points right here, when you're making graphics and you're stacking histograms or putting side-by-side box plots, they should what? And there's a big note you want to have. These are the learning objectives from this question that you can see right here. This one fails at it. What should graphics have? When comparing distributions, Monster Man, you lost your eye. When comparing distributions, the same scales. Great job, Emma, right there. They should have the same horizontal and vertical axes. So you see right here, these are the same. These are different. That goes to 25. That goes to 12. Bad news on that. So we want them to have the same horizontal and vertical axes. These do not. The interval widths are not constant. Yeah, it's a bit of a problem. Usually you just use a numeric scale for histograms, and they're talking about down here at the bottom where you've got like 85 and over, 85 and over, under 1 year, under 1 year. These are not the same sort of scales of data for bin widths. So maybe it should say bin widths should be consistent across. Like everything should be 0 to 2, 2 to 4, 4 to 6, 6 to 8. Can you do the Vermont? Yeah, and I think we got one from Noel, and Emma, you got it. We'll do Vermont right after that one. The bins do not cover all possible ages. There are gaps. I don't think there is gaps between them. I'm gonna go on a risk here. I don't know. Maybe I need to look closely. I mean, if it's saying you could be in between like 9.5, that's iffy. Okay, if we're gonna get anything wrong, it's gonna be that one. The vertical axis does not start at 0. It's hard to tell. It's hard to tell. Yeah, we're gonna get part of this wrong. We're gonna get this wrong. Ah, we got it right. That was hard to tell. Man, my person messing with me. Not fair. It appears that this starts at 0 by going by the units. It appears that starts at 0. If, you know, usually people don't say that they're 42.7 years old, which I am. I'm 42.7 years old today. Happy 0.7 birthday to me. People don't usually talk like that unless you're me. So you would be contained in one of these bins. 42 would be in the 40 to 44 bin. 44 would be in the 40 to 44 bin. So it's saying somebody's age is represented as a discrete number, not the decimal. So you can't be 44.5, which would be between bins. So, nah. Yeah, the last part's really tricky. I was like, oh, going. Okay, let's take a look right here. I think Noel had one, the U.S. Department of Energy. So let me put that here. 1 second. Oh, I was saying I had to sneeze, and I turned off the mute, and now I was saying my confidence monitor's across the room. Thank you, Noel, right there, for saying we can't hear you. Man, imagine if I did a whole question. The rest of office hours are muted. So thank you, Noel. Let's throw you 500 points for that right there. That would have not been good if the rest of office hours were muted. That would have been sad times for all of us. The U.S. Department of Energy, we got this right here, provides data on cars, and we can see right here the different types of cars. We've got compact cars, pickup trucks, and SUVs. Now, what do box plots analyze? Box plots let us compare groups. And what do box plots analyze? What do box plots analyze? So you should know when you see side-by-side box plots, you should think side-by-side box plots are a categorical X. So you go down here to the bottom. Class of car is categorical. Fuel economy is quantitative. and then you have what in a box plot? What am I marking? Compare the different groups, yes, and specifically we can compare what's between them. This is what you'd want to do on a test. Compare between classes, yep. And then what am I marking right here, which is what a box plot displays to you. Very important to know what a box plot displays and what am I writing on here. What is this called? Huge note, box plots are a visualization. Kind of, that is correct with 30 some points right there. Of the quartiles, the 5-number summary, the min, the Q1, the median, the Q3, and the max. And to remember the 5-number summary, draw yourself 4 quarters and put lines between them. And you can see right here, if you go up in terms of quarters, 25 cents each. So if you go up, you can do the min value, the median, a lot of people don't forget those, the max, and then you simply remember 1 quarter and then 3 quarters. And you can see which one of these are more spread out, where there's more range to compact cars and SUV. A big thing we like to compare between groups is the center, the median, to where you can see that these two have about the same median, but the compact cars have a higher median. You can also easily compare the range of the data by looking at the max to the min. Do not forget outliers. It's like I didn't go the tiniest bit down. And you can see which distributions have more of a range. Another metric of range is going to be to compare the IQRs, which is going to not be impacted by outliers, but you can see which of these has the greatest IQR, which is another measure of spread, which is a range also. I just did range, the interquartile range, which is another measure of spread. The IQR goes from Q1 to Q3, where the range goes from the min to the max. So this is, once again, a good review of what we get with box plots and how we should understand them and the information they display. So if you are trying to compare distributions, you can compare spreads by looking at their IQR differences. A lot of times we don't use range because it includes outliers, and outliers greatly impact the range of the data. So let's go look at the question, see what they want to know. Choose the correct answer below. SUVs generally get the best gas mileage. Well, is that true? No, they don't. It'd be the compact cars, so A is false. Compact cars generally get the best gas mileage. Okay, we're between B and C now. The first quartile for cars is above all the values of trucks. Okay, the first quartile, which is this, is above all the values of trucks. That's true. And so it is, I think the rest is, that's true. For both, no. You see, it's not above all the SUVs. So I'll zoom in on just that. I'll get down the information to only that. It's saying this first quartile right here is above, and the first quartile is this line right here. It's saying it is above all the values for trucks. That is true. But it's not above all the values for SUVs. That's false. So the first quartile is above all the values for trucks. It is not above, because there's still data right here. This is 25% of the data, and a good portion maybe, like technically all the dots could be here and there could be 1 dot there, but there is a value as high as right here, and that value is not an outlier, or else it'd be dots. Those are contained outside. So the right answer has to be that it is above all the values for trucks, and it's also above the third quartile, which that's what this is right here, the Q3 for SUVs. So it is true that it is above all the values for trucks, and it is true that it's above Q3. It's not above all the values. So it's above Q3. It's not above all the values, so that'd be false. So that narrows it down to this choice right here, and we've done it. We should have it right. Good question. Good, like, I know I'm showing the answers, but we should know how to look at it and then know what information we need, like where's Q1, where's Q3, where's the min, where's the max, where's the median. Nice job, Lima's got the study report, the load factors. And we got Vermont, doing Vermont right here. We're just rocking and rolling through these questions. Ooh, we need to do that one. That one gets students stuck. That one is a doozy. And it's got a trick that a lot of people tell me, they're like, I swear I got it right. My friend did this and I got it right. And I say, well, sometimes you get lucky. Oh, there's the Vermont. Ooh, this one's a tricky one too. Why do I have to do all the tough questions today? This one, it's the last question I think I've gotten wrong before. So let's not get it wrong today. It's not going to be an easy question. The histogram and summary, Vermont. Okay, so they're looking at public parks and number of sites per park right here. Pretty interesting metric. And I want you to see what you have on the histogram. First off, we know this. We say it every day. What is the shape of this histogram? I know I'm asking you for things you know, but you get points for saying them, and it's just review. You know Monster Man. You know what way this data is skewed. What way is this data skewed? What way is this data skewed? It is skewed. Emma's right there. And what way is it skewed? It's right skewed. Now, I'm going to do something to trick you really quick because I want you to see what happens right here and how a lot of students make mistakes. And don't worry if you make a mistake. I want you to tell me what way this data is skewed right here. So tell me what way this data is skewed. What way is this data skewed? Very clearly, this data right here is skewed what? Don't worry, a lot of students make mistakes on this. 30 points either way. That data right there is skewed whatly? How is that data skewed? It's the exact mistake everyone makes. Don't worry, we're throwing 500 points. Notice everyone got it wrong. What you did is you took it and did this. What do you notice about this right now? What do you notice about this? What do you notice? Do you see it? It's not left skewed. Because what's going on right here? The number line was reversed. Let me ask you this. These numbers right here, the tail goes towards the what side? The tail of the distribution goes towards the what side? The tail of the distribution goes towards the what side? Think of a four-letter word starts with H. Might look like it goes to the left if you have it wrong mirror imaged. And that's the problem. Sometimes things can be mirror imaged. Think of an H word that starts 4 letters. It goes to the what side? It goes to the, starts with an H, the high side. So if I go here to stack, and it makes it all look weird now, it's very clearly what skewed. It's very, very clearly what skewed. So just re-answer it again, because all I did was just take it and make sure the numbers go from 0 to the higher numbers now. Very, very clearly what skewed, right skewed. Don't worry, I did this on purpose because everyone usually gets it wrong because they're like, oh, if I just flip it downward. Because if you just say, oh, wait, let me go here, take the data, make the distribution, take a look at it, and you say, oh, that's left skewed, because your brain just takes it and turns it like that, right? That's what your brain does. But then the numbers are reversed because the high numbers are on the wrong side. Things are supposed to go to the right side. So really quick review of skew right there. We haven't put a test question like that in a long time, but that got so many students and it got good students. Usually you see data like this right here where the high numbers are on the right. 0 should be on the left. Noel, you said it correctly. And this is displayed correctly because right to the high, left to the low. And by high, we mean higher numbers. And I didn't even used to say right to the high, I used to say right skewed and left skewed. And that came up with the Monster Man, right to the high, left to the low. So the right side should have the higher numbers. The left side should have the lower numbers. That's the way it works. And if you have it reversed image down here, that's where it looks weird and you run into a problem because this is the wrong side. It's just mirror image. Okay, let's finish off this question right here. Good review of skew. What do you notice Brian is highlighting currently on the screen, which we will use to solve this question? Once again, I solve the questions and then I look to see what my Pearson asks. What is Brian currently displaying for you on the screen, which should more logically be written kind of. It should be written 0 and then 28 and then where's the other one? 43.5. What is Brian picking out from this data? What am I picking out? What is Brian removing? I've highlighted the what? Well, I highlighted the median. I highlighted 5 things. So remember our review from the previous question? What did I just get right there? What numbers did I just take out from it? The 5-number summary exactly, which is how we display a box plot, which is what this question is going to lead into. I've done it a few times. And this distance right here is going to be the what distance. That distance right there is known as Q1 through Q3. What is that distance right there? What is that distance? What is this distance called? That distance is called the what? Like this distance from Q3 to Q1. What is that called? What is that distance called? Like how far away Q3 is from Q1? The IQR, exactly. And the IQR has range in it, the interquartile range. So we call this the IQR. And think about it, range is just big number minus small number. So if you get the range of the data, you just take big number minus small number. If you want the IQR, you just take these two numbers and subtract them and get the range of the middle 50%. Because when you look at the quarters of the data, there's 50% of the data contained between Q3 and Q1, and that's why we call it the IQR, the interquarters, the two interquarters and the range they have. And it is represented by a box in the box plot. So here's where we run into an issue. We know it should go from about here, 28, and that's not perfect, but we'll deal with it. And it should go all the way up to 78 or so. Really? Let's try again. 28 to 78. There we go. The line in the box plot should be about here. Now, what in the world is going on? And now, here's the thing. If you take the box of the box plot and you copy it, you can see about where the fences would be. The fences are how many IQRs above Q3 and below Q1. The fences, and see if you remember the formula. This is a review question now. I'm going to show you visually here, and then I'm going to delete these. 1.5, great job, Emma, right there. It's 1.5. And the fences are just a graphical technique to show you where outliers begin and end. So here's what I want you to do. I want you to tell me, what is this formula solved out for? What is Q3 plus 1.5 IQR? So you have to find what IQR is, you have to find what Q3 is, and plug in those numbers. So give that a try right here. See if you can find it out, and we're going to find out something like 153. And here's the thing. The other set of data would not have outliers. The whisker would go down to the bottom of the histogram right there. Well, we don't need the standard deviation yet. We're just using IQR is going to be this metric right here. So you have to find out what IQR is. So go ahead and try to figure out what IQR is, and then we can see what Q3 is. So what are we going to get right here? We're basically doing the question without reading what they ask, and then we're going to answer their questions. So a huge note, once again, the fences that are just used, and great job, Emma, right there. Oh my gosh, Emma's got it straight in the chat right there. We're going to write what Emma said right here, is that Q3 is 78. You can see it over there on the side with the arrow pointing towards it, plus 1.5. And then the inside of this is 78 minus 28, which is 50. So it's going to be 78 plus 75 when you reduce the numbers. So 78 plus 75 equals 153. Now, what 153 tells us is the point at which outliers begin. So there would be, it might be that that's an outlier. It looks like it's not an outlier. It looks like it would go right to there. And then we'd have outlier, outlier, outlier. And we just drew the box plot. This is really good practice if you know how to know where your fences are at. And here's the thing. You remove the fences. They just tell you graphically where outliers would begin or end. The reason I didn't worry about low outliers is it's very clear that you can't have too low of an outlier. So how are people doing with this? All this information right here is going to be used to solve the problem now that we've taken in the information and we have what we need. I want to point out also, why am I ignoring the mean and standard deviation? So think theoretically why Brian is not really concerned about the mean and standard deviation. Why is Brian not really concerned about the mean and standard deviation? Emma said it perfectly. It's not normal data. I'm drawing that right there. Since it's not normal, we're not going to focus in on the mean and standard deviation because the data is skewed. The shape of the data dictates the proper center and spread. So because the data is skewed, doesn't really matter what direction.
It doesn't matter.
It's skewed, so we're going to use median and IQR. Let's go take a look at what they ask and make 100 on this question, or try to. So here we go. What statistics should be used for center and spread? Well, because it's skewed, we're going to use the median and IQR. The median is the proper center and the IQR is the proper spread due to the skewed nature. How many parks should you classify as outliers? There should be 3. And it's actually clumping in these right here because we don't know technically, and this is where it gets a little bit tough, is it could be possible that it goes to right here and those extra parks would be, it's 2, I guess? Yeah. It could be these 2 dots right here. So we're in one of 2 worlds. We're in either this world where those are right inside of our fence, or we're in this world where they're right outside. Does that make sense? I can't tell exactly where those parks are because I don't have the data. So if those parks are inside the fence, they would be here. And if they're outside the fence, they would be there. So we're in one of 2 worlds. They're within the not outlier range, or they are outliers. And then the whisker would go up to the highest point. This whisker is going up to those data points right there now. Let's take a look. I think we are actually going to draw it more like this. Let's find out. It'd be 3 to 5 data points. Values are more than 1.5 IQRs, and they tell you that right here. And it's really the ones that are above Q3. There's no low outliers. Create a box plot. They are using the star for the extreme. And if you notice right here, the highest value is 275. Which of these box plots are immediately eliminated since the highest value is 275? Use the highest, the maximum being 275 to eliminate 2 box plots right here. Use the highest value being 275 to eliminate 2 box plots. C and D are eliminated immediately, and now we should probably look at the differences in the IQRs. And once again, it's because C and D don't go up to 275. The IQR here goes up to about 78, it looks like, and goes down, man, that's hard to tell. It might go down lower than 28, I think. So I think this is the wrong one. And there are 4 outliers, it looks like. Oh, you can kind of tell because this has the points right there. Yeah, man, that's tough. This one's always a little tricky. What you want to do is think that this line right here is that at about 43, and it does look to be, and I think the other one's too low. So I think this is too low. That's not near 28. Like here, I'll show you visually. You have to think, is this more than 1/3 the way up? Is that where 28 would be on this number line? Yes or no in the chat. Is that where 28 looks like it would be? Because 28 is Q1 over there in the output. Is that where 28 looks like it would be on the number line? I think so. And that's, you can kind of, because 153, like that's, yeah, whoa, nice job. Good catch, because that's lower. So the fence being at 153, it's hard to tell, but yeah. So yeah, that would also be another metric. And this right here, that's going to be where it's just barely outside at like 154 or something. So we should get it right. That's tricky, tough one. The distribution of campsites, camp parks in Vermont it's unimodal. It's got the one peak and skewed to the right. The center of the distribution is approximately 30 to 40, somewhere in there. Oh, it's wanting the median, I think. 44, is it rounding it? Yeah. The distribution of campsites is quite spread out. These parks, with several high outliers, these parks have an excess, and this is where they want the line you found, the 153. So it's saying, where do outliers begin? We should have everything right. We did it. This is the point at which we found. It should say the fence begins at 153. So it was this number right here. How did people do? This is one of the tougher questions. We went over all the key things you should know from it, like Q3 plus 1.5 IQRs is where outliers begin on box plots. Q1 minus 1.5 IQRs is the low end for outliers, but there's no low outliers here. You should know how to draw a box plot, generally speaking. So try doing this right here. Remember, the 5-number summary is used for skewed data, and we use it to draw box plots. Really good, really tough question. So great job. That was a 15-minute question. Woo! We have another question, I believe. A study reports load factors. Let's go check that one out. A study reports load factors. How's everyone doing today? On that one. How is everyone doing? We do all the hardest questions here. Really tough questions. Study reports load factors. Here we go. A study reports load factors. You're welcome, Emma. Really good question. They're all great questions. Like, I like that we do the hardest ones, and I have had instructors ask me how to do certain questions. I've had instructors be like, how in the world do you do this question? I'm like, I'll show you. It's usually like ones you're hard learning. Like, there's so many questions. There's so many different things we ask. And I'm glad to help because, man, I'll tell you this quick story. So you're probably hearing this now. First semester I taught 201. I got stuck on a question and a student looked at me and goes, do you even know how to solve this? And I was like, and I'll still get things wrong here and there. So no one's perfect. And so shout outs to those instructors who ask other instructors to help them because I've been there. And shout outs to Emil and Missy and Terry and Charlie and Mike and everyone who's helped me. So shout outs. Nothing wrong with asking others for help, even if you're an instructor. What we see right here is the different years, and they're looking at domestic load factors. You can see the full data set right here, which has a different view of outliers, as in like there's more range to the data, as you can tell here from the lowest being around 63 to the highest being close to 90. But within each year, there's less variation. And thus, it'd be weird in 2015 to see something around 80, but of course 80 is close to the median for the full data set. Really depends on how you break down the data, how it looks. Don't love this question, a little tricky. So let's hear it here. The box plot for each year shows the same data, but the outlier they show is for different for months and years. Outliers are context dependent. Well, thank you so much, Noel, right there. I appreciate it. Data values that seem ordinary when placed against 1 year may stand out when compared against the entire data set. So that's kind of, let me make sure we got it in the right order. Data values that seem ordinary when placed against 1 year's data may stand out when, wait, is this not the same thing? Or, okay, here it is. Data values that seem ordinary when placed against the entire data set may stand out when compared from year to year. Oh, no. I was like, okay, let's read the right answer. Oh my gosh. It was messing with my brain. I can't explain it, but I just can't choose the right answer, Mal Pearson. Outliers are context dependent. They are. Data values that seem ordinary. I did this on purpose. Wink, wink. Data values that seem ordinary when placed against 1 year. So it's looking at the 1 year right here. It's looking at year to year to year to year to year. Yeah, and then look, you don't see many outliers. You only see one outlier. So yeah, they all seem ordinary. And then, but it's still the same. Like, it's down here, data values in the whole data set may seem ordinary. Like that value right there seems ordinary when you look at it the whole year. Come on, my Pearson, it works the other way too. That data values within each year. Yeah, in a way, Boxplots, sure, we can do that one here. I think Noel has one, right? Noel, did we have one? Make sure I got everything right here. We'll do that one next. In a way, Boxplots are like histograms. And drop that next question and I'll refocus my mind. In a way, box plots are like histograms. In a way, box plots are the opposite. No, they're not like histograms, they're the opposite. Oh my gosh. They're the opposite of histograms. In a way, they're the opposite. Here we are. And so what do box plots show you? Once again, what do box plots show you? I need to know, what do box plots show you? What's a box plot going to show you? I'll start writing on the screen. You should be able to do the same when you get to a test. You should start immediately identifying these aspects. What do box plots show you? A box plot is a visualization of the what? Can be used to identify outliers too. Box plots visualize the what, so you should write them on there. What do box plots show you? Huge notes. These things I say, you should just know. 5 number summary. And which of these, wink, wink, has a greater range? Great job, Nima, right there. Which of these has a greater range? The histogram or the box plot? Which of these has a greater range? The histogram or the box plot? I'm throwing points no matter what the answer is. Which of these has a greater range? Which of these has a greater range? Good guess. The same. The histogram goes from here to here. The box plot goes from here to here. They have the same So they just display the same data a different way. So it's the same data, the data still has the same range. Throw in some more points right there. I think of questions that might trick people, and I do ask tricky questions. The test isn't quite like that. But once you're like, oh, I see it, they have the same range, it's just showing it differently to us. Raptor, good to see you there. So when you think about this, you gotta be very careful with box plots. You always wanna look for what's is when you look at box plots. You always wanna try to identify what's is when looking at box plots. You always want to identify what's is when looking at box plots. Always want to identify what's is when looking at box plots. Because they impact the range greatly. Outliers, great job, right there. You always want to look for those outliers and make sure to include them when calculating ranges. So make sure to find those. Now, here's another thing. This portion right here, we'll call this portion number 1. This portion right here actually has, believe it or not, the same amount of data. Does that make sense? Like these two portions that I'm highlighting right now have the same amount of data. It's just that portion 1 is more compact, and you can tell it by how spread out the quartiles are. Does that make sense? So that's where the quartiles are. I've marked them in blue, and the more close the quartiles are, the more compact the data is, and the histogram kind of shows that better. Does everyone follow me on that? So the histogram gives you a better idea of the shape, and the box plot is really meant to see the 5-number summary. It just depends on what you want to see and how you want to display the data. So good stuff right there. Let's see if we can answer the questions now and take a look. Explain how you could tell by looking at the box plot where the tallest bars are. Well, we just went over that. The tallest bars are going to be where these quartiles are closest together because they contain the same amount of data, and the more spread out the like Q3 to max is, you can see right there, the more spread out the data is along the number line. So when we look at the answers, the areas in the box plot where the two vertical lines are closest together is going to be where the tallest bars are. Let's repeat that. The areas where the two vertical lines, which dictate the 5-number summary, are closest together is going to be where the tallest bars are, and where they're most spread out are going to be the shorter bars, because it's the same amount of data contained within those ranges, just more spread out if the bars are more spread out. Explain how both the box plot and the histogram can show you skew. Well, the quartiles get more spread out, indicates skew, and the histogram just has a tail. The box plot indicates skew because the minimum, the first quartile, and the median occur within a smaller range. And you can see it right here, small range for those, and then larger range for median, Q3, and max. And that's going to be right. Histogram, or the histogram is just skewed because tails on the right, large part on the left. Identify one feature. Oh, we did not do it. We didn't do it. We right to the high, left to the low, whatever way the Monster Man's tail goes, we shall always remember Monster Man. Identify one feature of the histogram shows that the box plot does not. Does the histogram show you the median? Does the histogram show you where the median is at? Yes or no? Does a histogram let you know exactly where the median is at? Does a histogram show you where the median is at? No, that's the box plot. So we know the box plot shows the median. So the box plot would be the one showing the median. The histogram and the box plot do show outliers both. You can see the little dots here at the side, very easily seeing the box plot are outliers. So we've eliminated those two, both the histogram and the box plot show that. The histogram shows that a very large number of values occur in the smallest bin. That's a little bit easier to see right here. I agree. The histogram shows that it's roughly uniform. No, it's not uniform on the left side. That's unimodal. And that's got it. There we go. Only one question wrong. Kayla, good work. Noel, good work. I'm going to pick a question right here that usually students get stuck on, and you would think it's an easy one. It's not too bad. It's the 5-number summary for students in a classroom, like 4th graders. Here we go. We'll do the a class of 4th graders. Are we able to do this one? The company sells frozen pizza. We might be able to. We'll try. Yeah, I think we can. I'm going to do this one here, and then we'll do that one. You got it. I want to make sure we get this one in the video because I get a lot of questions. How in the world do you do this? Or I did it, and I swear I got it right. I'm going to show you. This one has a trick at the end. Okay. A class of 4th graders. We're given the 5-number summary for them, and the 5-number summary can be used to compare center and spread. What is the center that we would get from a 5-number summary? The center you would get from a 5-number summary would be the what? So when using the 5-number summary, the metric of center to compare between groups would be what? When using the 5-number summary, which is often used for skewed data, The metric of center to compare between groups would be what? This is a test students took right here. The metric of center to compare between groups would be what? What is the metric of center shown in a 5-number summary? So now you have to know center terms, like measurements. The median, great job, Noel, right there. You are correct. It is the median. And the metric of spread right here is going to be this value right here, or the distance right there, Q1 to Q3. So I'm going to do it like that. So that is the metric of spread. You can see that girls had a higher median, higher center. Girls had a smaller spread from 4.2 to 5.2, which is a spread of 1. Guys had a spread of 1.4, 3.7 to 5.1. I'm just subtracting those numbers right here. How far away are those two numbers? And that is the interquartile range, the range of the middle 50% of the data. Let's see what they ask. And they're asking us, which group had the highest score? Well, these look boys right there. 5.9. Good show, the boys. Check it out on Amazon. We need a new season now. Which group had the greatest range? It does look to be boys again, and you can subtract the numbers. This is going to be 3.6. All I'm doing, and I'm doing it in my head, so if I make errors, I'm sorry. I'm just doing 5.9 minus 2.3 is 3.6. 5.6 minus 2.4 is 3.2. So it's boys once again. Which group had the greatest interquartile range? That's going to be 5.1 minus 3.7, so it's boys again. And 5.1 minus 3.7 is 1.4. So it's just asking, looking at the 5-number summary, do you know how to calculate range, max minus min? Do you know how to calculate IQR, Q3 minus Q1? And just figuring out which one's bigger. That's pretty easy. This one right here, which group generally did better? Well, it's going to be medians. And girls generally did better because of the median. And so we'd say here, the girls generally did better because their median was higher than the boys. That's kind of typical, like the center is the typical person within the distribution. Now here's the one students get stuck on. This is the one a lot of people get wrong because I'll show you. We'll pretend, and I might get it wrong, but let's do what people usually do. Boys had a 4.2, girls had a 4.6, and here's what people do. 4.4. They just average them like that. Will I get it right? I got it right. But not everyone gets it right. Let's show different versions of it and show when people get it wrong. Because I'll find one where someone gets it wrong, and here's where you would get it wrong. You'd say, but wait, it'd be 4.25 and that rounds up. So let's find out why this is wrong. It's because there's not the same amount of girls as there is boys. Very common for people to miss this last question here. And this is why there's 15 boys. I've redone the question, so I wanted to find one where you would get it wrong, not averaging it. There's 9 girls and 15 boys. So that means the girls had a 4.2. No, the boys had a 4.2. So you would do 15 boys times 4.2. And that's for the boys. Plus, and they would write the girls over here. The girls, there were 9 girls, as you can see right there. The 9 girls times the girl average of 4.3. And then you would divide by the total of 15 plus 9, which is going to be 24. So 24 is going to be the sum of individuals right here. There's 24 people. And if you think through it logically, there's more boys, so they're going to pull down the distribution. So if you do the math right here, you would get 15 times 4.2 is 63. 9 times 4.3, add the 63, divide by the 24. And there it is, and that rounds down to 4.2. And this is one of those ones I can't correct if you get wrong. So just take an extra moment and realize the mean will pull towards the group with more data. So there's a quick solve to it if you think logically, but also you can solve it out mathematically. And it's probably one of the random harder questions because you think, oh, I just average these two numbers, I'm good to go. But you have to look at how many boys and girls there are and times how many girls there are by their total, how many boys there are by their total, and then divide by the total individuals. 15 plus 9 is 24. So that is a random hard question right there.
It doesn't matter.
It doesn't matter, Rock.
It matters.
Okay, we got time for one more on frozen pizzas. The company that sells frozen pizzas. Let's go find that. And then it's going to be time for class. Oh, because I redid the questions. Oh, no, we still got it. The company sells frozen pizzas. Thank you, Noel, so much. thank you everyone who shows up or watches office hours later. Someone just wrote a random thank you nice thing on a video, and I'm like, oh man, frozen pizzas. You know, I am a frozen pizza eater. We eat probably, kind of sad. I eat probably a frozen pizza a week. I don't order pizza anymore. I just eat a frozen pizza, and then we get them for pretty cheap. Get them for like $5-6 a frozen pizza. Because I mean, man, you order a pizza, it's like $15 now. A lot of money. Okay, here we go. We're looking at side by side. Raptor knows what I'm talking about. Do prices appear to be the same across all 4 markets? Baltimore appears to be higher. What I immediately notice right here is when you think are things about the same, you want to compare the center and the spreads of the data. And Baltimore is kind of the weird one because Baltimore is a lot higher than the others in terms of median. You also have outliers here in Chicago, getting some cheap Chicago pizza. No one wants that. They just want New York pizza. Chicago deep dish. I'm not there to eat like a pie. I'm there to eat a pizza where you fold it up. You can't fold that up. Sorry, Chicago pizza lovers. I'm all about that New York pizza. Some Hard Knocks pizza. Some what is it? The new place. The donut place is making pizza. So, do prices appear to be the same? No, prices appear to be higher in Baltimore. Yes. Does the presence of outliers affect your overall conclusion about the price in the 4 markets? Yeah, Chicago's got a bunch of outliers. Chicago's outliers brings its average price down from the values. What's the overall conclusion? I would say Chicago's outliers are pretty big impact. Really? 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 Is it because medians? Oh, is that conclusion right there? Wow, that's a fun one to done. I think it's talking about the conclusion previously, and I wish they were more specific on which conclusion we just did. And what is the learning objective? If we're talking about medians, outliers do what to the median? If we're talking about medians and we're comparing medians, and it should say, does the presence of outliers, Braden, good to see you there. We're about to head off and do class here soon. It should say, does the presence of outliers impact your choice about medians? Does the presence of outliers impact your choice about medians? It would impact the average, and that's where they got me. But does the presence of outliers impact your choice about medians? That'd be a better question about Pearson. Does the presence of outliers impact your choice about medians? The answer would be no, because outliers don't impact the median. Until then, and you got it, Kylie, right there. We're going to start class here soon. My brain's going to reformat, whatever that means. Be back here soon. Great work. Ask those questions. We'll find videos. I'll get more questions right or wrong. You never know. Bye for now, everyone. Bye.